This is chapter 6, question 24. It says you throw a 3 Newton rock vertically into the air from ground level. You observe that when it is to 15 meters above the ground, it is traveling at 25 meters per second upward. Use the work energy theorem to find A, the rock speed just as it left the ground, and B, its maximum height. So our work energy theorem is work equals delta K. Can also be written as K2 minus K1, which can also be written as 1/2 mvf squared minus 1/2 mv initial squared. See. Once we have our equation here, we will be able to set it equal to negative mgy. The gravity is doing the work on the rock, which is thrown upwards. So the total work done by the gravitational force will be given by the change in potential energy, which would be, so we have work total equals mg times 0 minus mgy. Y being the distance the rock is thrown upward. So work total, that drops, equals mgy. So we will then go mgy equals 1/2. Once we get to here, we can solve our equation for our velocity final. So quite the equation, but we have all those values. So once you plug everything in, you should be able to get it nailed down. Let's see. Let me find my values real quick. So a little bit more math, I guess. This m cancels, that m cancels, that cancels. And then we can now go 2 times 9.81 times y. Y would be 15 meters plus our 1/2 times our initial velocity, which would be 25 meters per second, squared. And then that's multiplied by 2 as well. Take the square root of all of this and put it in my calculator. Once I put all this in my calculator, we come out to 30.3. meters per second. So that is our initial velocity. Let's see, let me read the question. Yeah, so that's our initial velocity as it left the ground. Now for question B, so at its maximum height, let's see, what is question B? Yes, to find its maximum height. To find its height, we can use this same equation here, but we're going to need to solve for y, and we are going to set velocity final at 0, because when velocity final is at 0, that's when it's turning around. So here we go. Now we'll do this with mgy equals -1/2 mv initial squared. Now we can divide by m, cancel those out. Gy equals that. Y equals 1/2 over gravity. Now we can use 30.3 meters per second for our initial velocity and 9.8 for gravity. And that gives you a Y of it was 46.8 meters. And that is problem 24.